innovator leader in experienced products, solutions, and digital services businesses. His visionary skills have led to an impressive track record of building companies from startup to mid-range, 200 million, to IPO and liquidation.
Thank you for the introduction. So let's take it from here. So as I said, my name is Ram Kumar. I'm the Chief Revenue Officer of SIERA.AI, a company dedicated to innovative technology solutions for safety and material handling. All that it means is making forklifts safer and smarter. Our session today will focus on artificial intelligence technologies such as machine learning, computer vision, analytics, and deep learning, how they can be useful in enhancing all of the applications for material handling, for safety within workspaces. We're talking about manufacturing facilities, talking about distribution centers, warehouses. We'll start with a little bit of context. So we'll rewind a little bit and then go fast forward. We'll set the context as to what are the data trends that are happening in the industry and how they are negatively impacting material handling safety, and how can it be corrected with AI technologies. To set the context here, we are a very interconnected, interoperable world over mobile, internet, and very soon 5G as well, right? So what does this all mean, right? In the last couple of years, we've seen e-commerce at a blistering pace expanding all over the world, which means that significant amount of online sales, online ordering, demanding fast turnarounds, and this has resulted in distribution centers and warehouses being built on a hub and spoke model outside of cities. And of course, this also means that most of these workspaces have gotten very crowded, right? With forklift traffic down the highways, overstocked shelves, some limited experienced staff to operate forklifts, and all this results in a big casualty of safety. And number one concern are accidents. So let's talk a little bit about accidents. The National Safety Council estimates that in 2020 alone, you had over 7,200 non-fatal injuries. And in 21, you had over 70 fatal injuries. And guess what? The EHS Today, which is a publication for safety directors, estimates that wherever there are forklift fleets of over 15, twice the number of accidents of other workspaces without forklifts. And all this results in over $100,000 damages each year, with 96,000 injuries, and on top of that, you have 50% labor churn, resulting in loss of productivity and efficiency. And how do we address that? Okay. And this is, again, another statistic, $200,000 damage or cost for any personal injury that happens on a work site. So everyone is trying for a zero accident workplace. The journey to zero is what we're going to be talking about. Okay. This slide captures the number one concern within enterprises. Worker safety is a number one concern with this survey that was done by the Warehouse DC Management Association. And this equipment survey shows the significant concern, even overriding company growth, is worker safety. And year on year, planned safety occupies the mind of management within enterprises. Now, you may ask the question, why is that so, given the fact that you have a lot of precautions, you have OSHA regulations, you have compliance in place, etc. And the reason is very simple, and it's because the forklift operators are just human. What if there's an extra mile, like the Siri on your iPhone or like Alexa on an Android phone, that can take care of safety while the driver can focus on productivity. And that is what simplistically we can define artificial intelligence to be. Providing an extra mind, if you will, to focus on safety. And the simple definition is capacity given by humans to machines. It's training machines to think like humans and operate like humans, right? I mean, we as humans have been given a basic operating code at birth, right? To do basic activities. And on top of that, with exposure experience, we've been trained to become scientists, musicians, whatever. It's the same principle. You train a machine to do some basic activities, basic operations, and then expose it to objects, expose it to the world, train, retrain. It's a continuous process. That's what's called ML modeling, or machine language modeling, or machine language training. So let's understand what are the components of AI and how do they help in material handling. I know there's a lot of talk about artificial intelligence these days in the media, and it's dangerous, etc. Everything can be dangerous, but however, if it can be purposed for safety in material handling as well. So what are we going to talk about here? We're going to talk about all the components of AI, like computer vision, machine language modeling, machine language training, deep learning, analytics. How do they help in safety applications? How do they enhance the functionality of each one of them? And how can they improve safety in the workspace? So let's start with the component that is really primary component in artificial intelligence, which is vision, machine vision, optical vision, coupled together with machine language modeling. And you may have seen cars running around the streets of San Francisco, maybe here in the book as well, with a lot of radar, LiDARs, sensors attached to them. This is this whole concept of self-driving or autonomous driving cars. Okay? So you've got all these optical sources from which you can derive data in digital form, right? And this data can be analyzed, can be filtered through to infer whether it's a human, or if it's a pallet, or if it's a box lying in the aisleway of a workspace or warehouse. And then label them accordingly, and then train the machine to understand what those objects are, and create the inference engine, create a baseline platform, and then add applications and host them. This is the core of a pedestrian detection system that we are working on at SIERA, and many others are probably doing the same, but it's a much more of a limited form than the self-driving autonomous cars that you may see on the street, because the objects are much lesser here. You're dealing with objects that are known to be such as humans, or partial view of a human, a hand or a foot or a leg or a head, or it could be also like a pallet or another forklift truck, etc. We're not going after every form of objects that other self-driving cars go after. But at the end, it is a component where we look at all of this optical data and apply machine language modeling to get at what are those objects that you have to maneuver around. Okay? And I'll talk a little bit more about the pedestrian detection system that we have currently and how we can proceed to a level of automation on it. The second big component within AI is analytics. Okay? And it traverses along two vectors. Okay? This is by applying deep learning algorithms, you make that extra AI mind provide you with analytics answering the question, what happened? Call it descriptive analytics, gives you a level of visibility. Right? We can train the algorithms to go to the next level of data to answer questions, why did it happen? Call it understanding. It's more like diagnostics. Right? We can train it to the next order to answer questions as to what could happen, what will happen. call it reasoning or predictive analytics. We can take it a step further to train the machine to provide for answers to how can we make something happen, how can we prevent something happening. Call it prescriptive analytics or just plain actions that you need to take. Now let's look at each of these. How do they enhance material handling applications? How does visibility or descriptive analytics enhance? And it answers the question, what happened? In this category of material handling applications, you have one big one called compliance. I'm sure all of you are familiar with being compliant with OSHA regulations. And most of you perhaps started with filling forms, right? Well, we have taken a step forward with digital compliance, meaning you can literally feed the forms, whether it's a forklift operator or an administrator, by filling the tabs on a screen, and all of the data is captured, call it telemetry, and that's ready for processing over the cloud. Now, a digital compliance application itself has been a step for many enterprise and workspaces because it's digitally transformed how they do things. It gives them a complete record of historical data. And for example, all of the operational details and provides for all the inspection details, provides for all the documentation of OSHA compliance. Now applying an AI mind to this, one can actually arrive at a risk analysis of the operations, of the operator, and of the vehicle, can arrive at a risk score for the vehicle as well as for the operator, and one can actually analyze the gaps in compliance, in OSHA compliance, for example, right? And pinpoint it in a very fast pace, perhaps every quarter or annually, such that actions can be taken. The same can be said of the impact monitoring application. Impact monitoring application is about recording every single impact, detailing it, the severity of the impact, damage that's happened, and also the near hits and misses that may have happened. And also identifying the coordinates, the GPS coordinates. Where did this happen inside of the workspace? Now, applying an AI mind to analyzing all of this data, one can then better define the severity of impact, whether is it 3 feet or a meter or 6 feet, etc., that one should be actually taking into account, because based on historical data and analyzing all of the audio and the video footage that comes with impact monitoring, one can identify what should be the parameters of the impact, parameters of the thresholds for the near hit or misses, and also identify all of those hot zones within a workspace, within a warehouse, within a distribution center, where there is more danger lurking. There's a lot of traffic, there's a turn radius that is really short, etc. Now moving on to identifying how does diagnostic analytics lead to better understanding within the material handling applications. Now, there are asset logs in which track all of the machine usage trends. An AI mind can analyze all of the machine usage trends and be helpful in identifying and matching machine to task, whether it should be a forklift or a loading truck or a pallet truck, etc. It can also analyze all of the operator behavior trends and then help in matching the operator to the machine. It can analyze all of the worksite performance statistics that have been recorded and provide for proactive planning, such that you have better efficiency and productivity within the workspace. You can do the same with the comparison of all of the analytics and the operational details that have been captured so far. Moving on here, let's understand how reasoning or predictive analytics can help in enhancing some of the material handling applications. To start with, the best example of predictive analytics is pretty much in this graphic on the screen. Here is a forklift operator backing up, and the forklift, the extra mind equipped on the forklift identifies it to be a human being within close proximity, and any movement backward could result in an accident, and as you see the screen in red, right, alerting. So it's the core of the pedestrian detection system where it identifies something bad will happen. It's time that I inform the operator, right, with some form of an alert, either it's an audio or a video alert, okay? The same thing can be said of other applications as part of this predictive analytics family of applications, like asset maintenance. It can flag assets that have not met the maintenance schedules. Same flagging operators who have not gone through the training schedules. It can also do the same with the space, time, cost optimization. That is a significant imperative within every single distribution center and workspace to analyze all of the assets, the operators, and provide for, and the space where a lot of the hot zones are, to optimize the best track and the best routes and the best schedules. And moving on to how does the AI extra mind help in prescriptive analytics or action? And this video here is a clear example of that. Here is an operator not knowing that there's a person right behind, backing up, and immediately the equipment is slowed down and brought to a stop. So it can result, the AI mind can result in speed control, slowing down the speed, and also bringing it to a safe stop. And better still, it can also provide for better access control. Denying access, meaning you cannot even start the ignition of the machine if you're an unauthorized person, if you're not certified to operate it, and if your risk score is extremely high. It can also result in better behavior change, right, by inducing the operators to operate on safety first kind of behaviors, wearing a hat, wearing a seat belt, wearing the vest, etc., right? And also avoiding some of those hot zones where there's a turn radius that is rather sharp, etc. So having said all of this, I just want to say a few words, putting in a plug for who we are, what we are as a company. We are all about forklift safety. And as a company started in 2017, we focused initially on compliance, moved down to digital compliance, and then on to impact monitoring, access control, and now into pedestrian detection systems. Right? So it's been a gradual path, and we have helped the productivity and efficiency within a lot of enterprises by tracking more than 1 million incidents. Right? And we've got quite a few well-known logos as part of our customer install base. Our technology is really simple. So it's all about retrofitting your existing investment in forklifts and other material handling equipment, right? With 3 basic components. One are sensors, both front and back, with a laptop or a notebook computer that comes in 2 forms, a rugged version for use outside, and a regular version that can be used indoors, and a connectivity through the cloud onto our cloud servers that collect all the telemetry and do the necessary analysis on them and present it back on a dashboard that's available to both administrators as well as the forklift operators. So that basically constitutes our solution. And you have a roadmap, and just like the roadmap that every company has in terms of arriving at full automation, it's about starting with an assist for the driver, with alerts rather. So an audio and video alert, moving on to a full pedestrian detection system, and then moving on to vision assist, and then to a full automation. So we are currently there in the blue box, that proceeding with the roadmap to automatic speed control, stop, and then autonomous vehicles. Some companies have started the other way around, full automation going towards compliance, etc. That brings me pretty much to the end of my slide. I'm open to questions.